impaired recognition of emotion in facial expressions following bilateral damage to the amygdala. By paper by R. Adolphs, D. Trainell, H. Damasio, A. Damasio, presented by Max Philos. Okay. This case study was conducted to learn more about which brain functions the amygdala, located in the temporal cortex, was responsible for. It was a common misconception preceding this test that the amygdala took in visual input that was highly processed and that it dealt with forming, you should film me,
Okay.
emotional responses surrounding visual stimulus. It was observed in animals that it had neurons which responded specifically to faces. This led some neurologists to expect that damage to the amygdala would affect the ability to read facial expressions. Most of the evidence about this part of the brain, however, came from either animal testing or epilepsy patients. Some types of epilepsy are caused by damage in the medial temporal lobe, which is important in memory and visual processing, which is why visual stimuli are a trigger for epileptic fits. However, the medial temporal lobe includes other brain sections like the hippocampus in addition to the amygdala, so none of the symptoms from those epileptic patients can be used to diagnose what the amygdala individually is responsible for. This is the reason why the subject of the case study, SM, was of such great interest to the neurologists who conducted the test, because SM had a rare iteration of the already rare Urbach-Wiethe disease, which almost completely degraded her amygdala while leaving the parts surrounding it intact. Because of this, any dysfunctioning in a test would be purely the fault of her amygdala's absence if there was some kind of neurological justification for the dysfunction. Before the test, SM was checked for any possible factors that would falsify the test. She was found to have an average IQ, sufficient eyesight, and sound mental health. If she was not standard in these factors, it could mean abnormalities in her responses were because of these factors and not her amygdala damage. The first test was based on responses to 39 of different facial expressions, and the subjects were asked to rank how intensely they expressed 9 emotional adjectives, giving the faces a score of 0 to 5 based for each adjective. The tests included SM, 12 brain damage controls of similar IQ, and 7 neurotypical people. Compared to the controls, both neurotypical and brain damage, SM assessed fear and surprise being expressed on the faces as far lower than the others, falling 2 to 5 standard deviations below the neurotypical control mean. SM was then tested on their ability to recognize the identity of faces as separate from their emotion, being shown faces of old friends and people she used to know, and being asked to identify them, as well as being shown new faces and being asked to remember them and name them later. She performed perfectly in these areas and recognized old faces and developed new recognitions of faces. The rating data for this test was visualized using a multi-dimensional scale, which mapped out the response towards each individual image on a Euclidean plane. The similarity of the emotions would mean they would be closer together on the plane. For example, scared and angry were closer than happy and sad were. The sample photos were designed in such a way that each of them represented a gradual shift through a cycle of emotions leading back to the start. In accordance with this, the neurotypical responses resemble a circle where each emotion is equally spaced out, representing a full use of the range of rating combinations the subjects were given. However, SM's examples resemble 3 clumps, equally spaced out but with large gaps in between them. Even removing her abnormal response to fear from the data, these strange clumps still appeared. A T1 MRI scan was conducted, which is a type of MRI scan which prioritizes the visibility of brain fat, ideal for scans that are focusing on the size of parts of the brain. 2 coronal MRI scans were taken to capture the different parts along the medial temporal lobe, displaying where it was disintegrated and where it was normal, and the images proved that only the amygdala had been damaged. The neurologists organized some findings based on the information. 1. The damage in the amygdala caused the lack of ability to read fear in another person's face. This was supported by how low she rated afraidness in the face of the examples compared to individuals with no brain damage and different kinds of brain damage. The conclusion has additional validity because it correlates with past research about the amygdala. And number 2, that SM only showed the ability to recognize a primitive form of emotions. This was just justified by the way she would rank scores lowly, which melded 2 feelings together. For example, if there was someone's face who was traditionally seen as sad and disgusted at the same time, she would rank sad highly but disgusted lowly. This correlates with the gaps shown in the multi-dimensional scale. One final piece of validity is that they can draw upon the fact that she was relatively unsuccessful in her social life before the test, potentially caused by a low ability to identify emotions and a poor ability to identify fear in someone's face, which would make someone relatively less likable, thus corroborating the test claims. The second test also identified them to believe that the second test also caused them to believe that identifying a face and assessing the emotion of a face are not connected neurologically, because although her brain damage could be seen as causing a disorder in recognizing emotion in human faces, it didn't affect her ability to identify people from one another. Can you zoom in on this? Okay. And then turn it off. I scroll down, and then, yeah.